Hi, Miss Barber here. Here are some examples similar to the problems of your homework number 4. Use polynomial fitting to find a closed formula for the sequence a sub n equals 6, 11, 20, 33, 50, 71. Assume a sub 1 equals 6. Let's begin this polynomial fitting problem by looking at the gaps between each of the terms. So we look between 6 and 11, and that is a gap of 5, or an increase of 5 if you want to do that. From 11 to 20, the difference there is 9. From 20 to 33, that gap is 13. From 33 to 50, that gap is 17. And between 50 to 71, the gap is 21. We see that the gap is not a constant value, so let's look at the secondary gaps. So between 5 to 9, we see 4. 9 to 13, we see 4. 13 to 17, we see 4. 17 to 21, we see 4. This tells us that we have a delta 2 constant of 4. Delta just means change. And to find the polynomial fitting, we would use the formula a times n squared plus b times n plus c equals a sub n. Now, we are given a sub 1, and we could get an equation, a system of unknowns, but we can make it a little bit simpler if we just look for a sub 0. We go back 4 spaces, and so if I minus 4 takes us to 1, and for the term of the sequence, we subtract the 1, we get a sub naught equals 5. So let's begin with the a sub naught, and we know that the a sub naught is going to be equal to the 5, and let's compute a, put in 0 squared plus b 0 plus c. A subscript 1 is 6, and we'll do a, put in 1 for the n, plus 6 times 1 plus c. And for our next equation, let's look at a sub 2, which we know is 11. So you have a 2 squared plus b 2 plus c. So the system of equations that we get c equals 5, because a times 0 is 0, b times 0 is 0. Then we get a plus b plus c equals 6, and 2 squared is 4a plus 2b plus c equals 11. Let's continue, but putting in c. So a plus b plus 5 equals 6. So if we subtract the 5, 6 minus 5 is 1. Then we'll have 4a plus 2b equals 11 minus 5, which would be 6. Solve this system of linear equations. At this point, you're more than welcome to use your technology to solve it, but just for practice, let's do elimination. I'll solve this by multiplying the first linear equation through by -2. Then the 4a plus 2b equals 6. Distributing the -2 to the first equation will give me -2 times a minus 2 times b equals -2. Let's vertically add. 4a minus 2a is 2a. The b's cancel. 6 minus 2 is 4. I get a equals 2. So I've got c equals 5, a equals 2. The only other value I need to solve for is b. Let's use the equation a plus b equals 1. Since we've computed a to be 2, 2 plus b equals 1, and solving for b is negative 1. Into the polynomial fitting equation, we have a n squared plus b n plus c is equal to a sub n. Let's put in our values. The a is 2, so I'm going to move down here a little bit and write a. We have a sub n is equal to, putting in 2 for the a, 2 n squared, minus 1 n plus c is 5. The minus 1 looks silly, so let's just write it as a sub n equals 2n squared minus n plus 5. Now we're close to done, but it's important to check, so let's pick a number. Let's look at the fourth term, okay, a sub 4. Then I'll have 2 times 4 squared minus 4 plus 5. That gives me 2 times 4 squared, that's 1632, minus 4 plus 5, and that value ends up being 33. So let's go back and check what the original sequence is. The fourth term, 33. 1, 2, 3, 4. Yep, it checks. Find a recurrence relation and initial conditions for the sequence. D sub n equals 1, 3, 10, 33, 109, 360. A recurrence relation, we're looking at something more like a Fibonacci sequence. We need to go back or refer back to some initial terms. This always takes me a few attempts to get there. So my first attempt, which will be wrong, right? And we'll say d sub n equals, and I'll notice that from 1 to 3, that's exactly triple. 3 to 10, well, 3 times 3 is 9, so it's about triple. 10 to 33 is about triple. 33 to 99, so if I do 33 times 3, that's 99. That's exactly triple, but to 109, it's off by a little bit. And 109 tripled is 327, and so that's still off from 360. So my initial pass is going to be that a subsequent term, d sub n, is 3 times the previous term, plus some kind of error, some epsilon. Okay? So let's look at what that would be. I just said them, but we'll do it again. On the first pass, let's look at a sub 2. 3 times 3 is 9, and 9 to 10 we're off by 1. Let's try the next one. 3 times 10 is 30, and from 30 to 33 we're off by 3. 33 times 3 is 99, and between 99 and 109 we're off by 10. 109 times 3 is 327, and the difference between 327 and 360 is 33. Now I'm seeing a pattern that matches the terms of the sequence. 1, 3, 10, 33, and the errors are also 1, 3, 10, 33. So let's fix that error. So d sub n is 3d previous, and then we add the term even before that. Now we're close to done, but let's see. I want to check. Let's start with 33, so that would be the fourth terms. D sub 4 is going to be 3 times d sub 3 plus d sub 2. So 3 times 10 plus 3, so that checks. And so when we set this up, we need to have initial conditions, d1 and d2. We'll let d1 be the first term, d2 is the 3, we've checked it, and now we have our recurrence relation. Use the characteristic root formula to obtain a closed formula for the recurrence relation. E sub n equals E sub n minus 1 plus 6 times e sub n minus 2 with e0 equals 1 and e sub 1 equals 4. We will set this up using the characteristic root formula technique. And so to do that, let's set this equal to 0. You get e sub n minus e sub n minus 1 minus 6e sub n minus 2 equals 0. Characteristic root formula lets us write this as a quadratic of x squared minus x minus 6 equals 0. And this factors nicely into x minus 3. X plus 2 equals 0. So the x values are x equals 3 and x equals negative 2. Now let's put it in the a sub n form. So we'll get a sub n is equal to a. The x is where we're going to put in the 3. So 3 to the n plus, then we're still needing the b, negative 2 to the n. This is when we need to use the initial conditions, the systems of equations. And so using e sub 0 equals 1, I would write this as e sub 0 is 1 and put in 0 for the n. So we'll have a times 3 to the 0 plus b times negative 2 to the 0, which is really nice because those go to 1. And then we have e sub 1 is 4. So 4 is equal to a, and then 3 to the power of 1 plus b times negative 2 to the power of 1. The system of equations that we get will be, so copy that again, is going to be, let's see, a plus b. Remember, anything raised to the 0 is just 1. And for the second equation, I will have 3a minus 2b equals 4. I'm going to trust that you can solve a system of linear equations, and when you do, the results that you get are a equals 6/5 and b equals negative 1/5. Let's continue. So let me copy again. A equals 6/5, b equals negative 1/5, and we need to replace in the form a sub n equals a 3 to the n plus b times negative 2 to the n, the values we got for a and b. So a sub n is going to be 6/5 3 to the n plus negative 1/5 negative 2 to the n, and we typically don't write this as plus negative, so let's just get rid of the plus. Here we go.